HTTP caching is a cache that is managed through HTTP headers, and is often stored in the user's web browser, but not always. Now, if you aren't familiar with HTTP caching, check out this excellent caching tutorial by Mark Nottingham. It goes through the basics, and it's a really excellent read. Now, this kind of caching can make a site feel a lot faster because it's reading from a cache that's so close to the user. So, how do we add this kind of cache to our Rails application? Well, it turns out that Rails has some HTTP caching enabled right out of the box. So let's first focus on what Rails provides by default. I'll use this curl command here to see what the headers are for a request to a local Rails app running in development here. And so this is what the response header contains. And you can see I want to focus on this one right here, etag. So this is a unique string that's generated based off of the content in the response body. So this means if you make a request again and it has a different response body, it's going to have a different etag. But if it's the same response, it'll have the same etag. And this is generated by default in a Rails app. Now you think if you run the same request again, it should have the same etag, but you can see here that this etag is actually different than the one that was generated earlier. So why is it that the same curl request has a different etag? Now the issue is that the response body is actually changing slightly with each new request. You can see if I view the source in the web browser here that there's this tag called CSRF token, which is a unique string that's going to be different for each new visitor. Now if I reload the page in the browser here and view the source again, this token is actually going to stay the same in the browser because it's stored inside the session, which is carried across between requests. But since our curl command doesn't store the cookies, it's going to have a different response body each time. Now we can simulate the browser cookie storage by storing the cookies in a cookie jar. Let's call it cookies.txt. And then when it makes a request, it's going to write to that file. And then we can read the cookies using the -b. And then that will actually read from that same cookie jar. And therefore, we get the same etag here because the response body is the same. All right, but what does this etag have to do with caching? Well, when the browser caches the response, it's going to assign this etag to it. And then if the user requests that same path again, the browser is going to send that etag through the header through something called if none match. And then it will pass that etag into that. And then when we submit this request, notice that our response is a little bit different here. We get 304 not modified instead of 200 OK. So this tells the browser that its cache is up to date and it should read from that. So this makes it appear a lot faster to the user because it's reading from the local cache instead of downloading the full document over again. Now the request will still just take as long on the server side because it still has to generate the full response so it can generate that etag and then do the comparison. It's not going to save any resources on the server, it just makes it appear faster to the user because it doesn't have to download the full response again. Now it is possible to make things more efficient on the server side as well by customizing how an etag is generated. And I'm going to do that in the show action of the products controller, which displays a given product. So here's what that product show action looks like. It's very simple. It just fetches a given product. And if I know that all the dynamic content on the page is based on the actual product, I can use this to generate the etag. And to do that, I can call fresh when, and then pass in an etag option, and then just pass the product right into it. And this will use that product to generate the etag. And internally, this is going to end up calling cache key on the product for determining the tag, which is based on the updated at column for that given product. So this means that when you update that product, it's automatically going to generate a new etag, so it'll auto-expire the other caches. Now this fresh when call does a couple of things. First, it checks if the etag passed into the request matches the etag for this product, and if it does, that means that the cache is fresh, so it's going to change the default renderer to 304 not modified and instead of rendering the actual template for this show action. Otherwise, if it doesn't match, it'll just continue on and render the full template for the show action. So now let's try this out again with a curl request, and we no longer need to send in our cookies because the etag is now dependent on just the product and not the whole response body. So let's try visiting a specific product here, and then note the etag there, and then when we visit another one, that etag stays the same because it's the same product and it hasn't been updated. And if we run that same curl command again, but this time passing in a header option like we did before with if none matching that given etag, it's going to return again 304 not modified, but this time it's not going to render the template because we have that fresh when call in there. And you can see that if I tail the log here, you can see that when we made the request earlier, it included the show template, it rendered it out, but when we made it by passing in the E tag, it did not include the show template because it returned 304 not modified, so it used the cache instead of actually rendering the template, so that saves some performance on the server side. Now the fresh when call works great in our show action here because we're using the default rendering behavior, but let's say you had a respond to block here, then it's not really going to work very well because this explicitly renders something and it's not going to fall back to the default renderer. In that case, there's something called stale. You can say if stale, then handle any explicit rendering or maybe some additional queries or whatever you want to do inside of here if the cache is stale. Otherwise, it's going to return the 304 not modified. So that's an alternative syntax you can use if you want. In this case, though, I'm just going to stick with the fresh when call because that's all I need here. Now, something kind of cool about this etag option is that it allows you to pass in an array of multiple objects into it. So if the page's dynamic content is dependent upon multiple objects, you can pass those into here. Maybe the current user, if that's displayed on the page, just pass them all into here and that etag will be generated based on all of the objects passed in. Pretty cool. So that pretty much covers it for etags. Now there's a header option that goes right along with this called last modified, and you can set that through the fresh when call as well. So we can say last modified, and then this should be the time that the document that's returned was last updated. So we can say product.updated at, which is when that document last changed. So now when we make another curl request to that same show action, it's going to include this header called last modified, which includes the time that the product was last updated at. So the browser can use this in a similar way to etags to determine if its cache is still up to date. And it does so by passing in this header option called if modified since, and then passes in that time. And then in this case, it hasn't changed since that time, so it's going to return 304 not modified. But if we pass in an earlier time, such as 53 seconds, then it's going to return the full response with the 200 OK. Now it's a good idea to set both of the etag and last modified options when you can. And if you're using Rails 3.2, there's a more concise way to do this by just passing in the object directly into the fresh when call, and it will generate both the etag and last modified based off of it, similar to how I showed here where it just calls updated at on the product that's passed in here. Now there are some things you could do with last modified that you can't do as easily with etags. To demonstrate this, let me show you here in this index action which displays all of the products. But first a side tangent on how we fetch all of the products. Notice I'm doing product.all here, which is going to perform a database query immediately here in the controller action. Now when you're working with caching, you should try to perform a database query as late as possible so that way it might fall under the cache. And in this case, we don't really need the products until it gets to the view, so we should not actually perform the query here. Now, if you do something like an order clause on here, then that'll automatically not perform the cache. But in this case, to fetch them all, we could do scoped on here, and that way is similar to product.all, but it doesn't actually perform the database query until you're trying to actually work with the products. So now with that change, we can make a fresh when call here to set the last modified time to that of the product's maximum value in the updated at column. Now this does end up performing an extra database query, but it's only fetching one quick value to determine if the cache is up to date. And if it is, that means it doesn't have to actually render the whole view template, and that means it won't end up fetching all the products from the database. So this may or may not give you a big performance boost depending on how many of the requests come in that have a cache. So it's a good idea to always test and performance benchmark it to determine if this kind of change is worth it. Alright, so far I've covered two different response headers, etag and last modified. Now there's one more I want to cover in this episode, and that is cache control. And in here you can set a variety of options to determine how the caching should behave. And notice that Rails sets some default options here automatically. Now this option right here, must revalidate, is pretty simple, so I'll cover that first. Basically it just says that it should always check with the server before it serves up a cache to ensure that it's up to date. That's referred to as validation, so that's what that means. Now another option here is called max age, and this specifies how many seconds the cache can be served to the user without contacting the server for validation. So this means, like, let's say this was set at 30, that means that the cache can be served to the user locally for 30 seconds, and once it's past that time limit, it should contact the server to see if the cache is still valid. Now you can customize this max age option by going into your controller and calling this method expires in, and then passing a duration such as 5 minutes. So now when I make that request again, you can see that the max age option is now set to 300 seconds. So this means the local cache will be considered valid for 300 seconds, and then after that amount of time it's going to check with the server to see if it's still valid, and if it is, then it's going to again reset this counter so it will be considered valid for 300 more seconds. So this leaves us with one more option here, and that is private. Now this means that the cache should only be stored for this specific user, which is usually through their web browser, and not stored in a place where multiple people access it, such as through a proxy. Now you can customize this behavior in pretty much any of the caching methods, whether it be an expires in, or fresh when, or stale. Just pass in the option of public and set it to true in one of those method calls, and that will change that header. And now when we make the request again, you can see that the cache control now says public instead of private, because this means that it can cache it in other places besides just on the specific user's browser, such as a proxy. Speaking of proxies, Rails now automatically includes rack cache in production. This is commonly known as a reverse proxy cache or a gateway cache, but don't let the name confuse you. The core concept is pretty simple. There's an excellent guide by Ryan Tomeko called Things Caches Do, which explains this nicely. Basically, rack cache sits on your server in between the user's requests and your Rails application backend. Now normally HTTP caches are only stored on the user's side in their browser, but if rack cache is installed and the cache is marked as public, it's going to be stored inside of rack cache as well. There's a nice example of this if I scroll down a bit. Let's say that Alice makes a request to our server and it's not cached, so it's going to go to the Rails backend, and it's going to be tagged with the max age 600, so it's going to be valid for 10 minutes. And let's say it's public, so rack cache is going to store it locally on the server side, and it's going to be sent back to Alice. Now let's say another user comes along, such as Bob, and he makes that same request. Now even though he doesn't have the cache stored on his local browser, rack cache does, so it's not going to hit the Rails backend because it's within the 10-minute limit, so it's going to send it directly back to Bob. Now rack cache also supports the validations of the date modified and etag headers, so check out this full article for more documentation on how that works. Basically, think of rack cache as sort of a mini in-between browser. It caches just like the browser does, but it works for all users and only for public caches. As I mentioned earlier, rack cache is only available in production by default, but if you want to try it out, you can enable it under the development config file. Just set the perform caching option to true here. Now with that option set, if you run the rake middleware command, you can see that the first rake middleware here is going to be rack cache. So it'll go through that before it hits the rest of your Rails application. Now you'll need to restart the server after making that change, but then when you visit the show action of the products controller, it's going to cache this in rack cache because it's specified as public, and then the next time you hit reload, it's actually going to serve it directly from rack cache instead of actually hitting the Rails backend. Now a word of warning about setting public to true. Be careful about possibly sensitive information that you might have on this page, or information that changes depending on which user is accessing the page, because this given request might be cached for every possible user, so you don't want to store sensitive information in the cache. Now here's a quick tip. If there's some user-specific information that you don't want stored in a public cache, such as maybe the CSRF meta tag in the layout file here, you can hide it dynamically by calling unless response.cacheControl is public. And that way it won't show up if it's set for a public cache. You should probably do the same thing for the flash messages too, so that doesn't end up being inside of a cache that's public, visible to all users. So now that we know all about these fancy HTTP caching techniques, the final question is, when should we use it? How do we know what cache to use and when? First of all, avoid premature optimization. Wait until you know which key pages are going to be hit often and focus on caching those first. If the page doesn't change frequently, and if it doesn't matter if it's a little out of date, the expires in cache is the way to go because it'll lead to the fastest user response because the cache doesn't have to validate with the server. On the other hand, if the page changes more frequently, just stick with fresh when or stale because you have more control over when the cache expires. Or, if you can, use both together because they really make a great combo. And finally, only set public to true if you don't have sensitive information on the page, because that's going to store in the public cache. Well, that finishes up this episode on HTTP caching. I hope you found it useful.